Okay, so let's continue number 2, solving for x of t. Well, we're not solving. We have x of t, but we're trying to prove, right, that this expression matches what we have in the book. So here we're just again going to use some algebra. So we have 3 terms here, right? 1, 2, 3, and we can definitely factor out a v naught over k from these guys right here. So I'm going to go ahead and do that. So I'm going to take out v naught over k, and I'm left over with negative e to the negative kt plus 1, and then I still have my x naught here, right, because that doesn't have a v naught over k. And I'm going to go ahead and just rewrite this as 1 minus, you don't have to, just looks nicer like this, plus x naught. And you'll notice that, right, this matches exactly what we want. So that is the end of the proof. That is the position at time t. And so part B was, let's see, it was conclude that the body traveled only a finite distance and find the distance. Okay, so let's move this a little bit. Well, we found our x of t, so as t gets large, right, what happens to v of t? Well, if t is getting large, we know we're going to take the limit. So the limit as t approaches infinity of our x of t, so I'm just going to go ahead and write our position function that we found. Right, and we want to know what the limit is. I mean, this is, again, just a Calculus 1 problem. So let me just go ahead and, let's be neat here. So a limit review if needed. So I'm going to break up my limits. So the limit as t approaches infinity, right, I can break this guy up as v naught over k plus, actually minus, because of this guy. Let's see, the limit as t approaches infinity of e to the negative kt, right? So I just distributed here. So I have 3 limits, and we know the limit of a constant is just a constant. The limit of this is also a constant because it's not a function of t, so that's just v naught over k. And then our last guy here is the limit as, right, so we have this exponential function. Well, I mean, this guy, if you quickly graph it, right, e to the negative kt, right, is an exponential function that's decreasing. So as t approaches infinity, right, it gets really large, this eventually, right, the height is going to approach 0. It's going to be a horizontal asymptote. So this guy really approaches 0. So we don't need to write it. So the limit as t approaches infinity is equal to, so let's just maybe write limit as t approaches infinity of our x of t, right, is equal to this guy. Well, I mean, this is a fixed value. This is the actual distance traveled. So we have, well, we're basically done. So note that as t approaches infinity, v of t, the velocity at time t, approaches 0, meaning, right, our body, which is going to be the boat, right, the boat is eventually, it's going to stop, right, because the velocity is approaching 0. So that is number 2. Hopefully that makes sense.